In this problem, we are asked to find the exact values of the trigonometric function if theta is in standard position and the terminal side of theta is in quadrant 3 on the line y equal to 3/4. The first thing that we will recognize is that on this line, it passes through the point x is 0, y is 0. We also know that since our slope is 3/4, the slope represents a rise of 3 for every run of 4. If we graph that in quadrant 3, we would see that our run of 4 would produce a rise of 5 to get to that origin. We could also plug in a -4 for x, and if x is equal to a -4, that would give us another point on that line, which is -3. Sketching a graph of that line. We now know theta goes from the standard position, or the positive x-axis, counterclockwise to that terminal side. We also know that a point on that line is given by x equal to -4, y is equal to a -3. We are now ready to find the values of our 6 trigonometric functions. We would first find r, knowing that r squared is equal to x squared plus y squared, or a -4 squared plus a -3 squared. 16 plus 9 is 25. That gives us r equaling to the square root of 25, or 5. We now know that the sine of theta is given by the y-coordinate over r, which is given to us by a -3 over 5. Cosine of theta is the x-coordinate over r, which is a -4/5. Tangent of theta is a ratio of sine over cosine, or y over x, which is equal to -3 over a -4, or a +3/4. We are now ready for our reciprocal identities. We know that cosecant of theta is 1 over sine, or the reciprocal of sine, which is equal to a -5/3. Cosine and secant are reciprocals, where the secant of theta is 1 over cosine, or a -5/4. Finally, cotangent of theta is the reciprocal of tangent, which is equal to a +4/3.